Good evening to all of you. Welcome you guys. Welcome you all. How you are doing, all of you? Very good evening to all of you. Welcome you all. So I think we are in live. So all of you do comment. Do comment. Are you able to hear my voice or not? Is audio video is clear? Is audio video is clear? Do comment, everybody. Chalo, let's start our discussions. Chalo, let's start our discussions. Good evening to all of you. Welcome you guys. And we have a small announcement from Unacademy, that is Pado Kelo Crackero. This is the announcement from Unacademy. So we are starting a new series with the top educators of India from July 1st to August 15. For the electrical and EC and electrical both branches we are running. And you can enroll for these courses. And so the features of Unacademy Plus classes, with the Unacademy Plus classes, the live interaction with the polls can be done, and raise the hand, never miss a class, you'll get a regular notifications. Lecture notes is available, you can download after the class, you can download the complete notes, you can download, and anytime, anywhere you can access the classes. And we have a daily scholarship test. There is a daily scholarship test, you can avail the scholarship. And these are the new batches we are running from the 29th June onwards we have started, and you can find the top educators of India, you can find, right? And this is the 29th June new batches you can find. As we know, we are running the digital, we are running right now, and target batch from June 29th onwards we have started, and vision GATE and ESE 2024 batch you can find the top educators of India. And as you might know, here from the 13th July onwards, screen is blurred. Check it, all of you. Are you facing any problem? Did any of you are facing this problem? What are the remaining fellows? You are facing the problem from 13th July. From 13th July onwards, we are starting the signals and systems. We are starting 13th July onwards. We are starting the signals and systems. We are starting. Right. I think so. So Anmol, एक बार आपका net check करो. So with the, and you can see that by the features of Unacademy, the plus features are the top educators are available, and doubt solving and study notes available, test series. In addition to this, for the iconic students will get additional benefits. Iconic students will get additional benefits as physical notes, one-to-one mentorship, strategy and study program, as well as live audio interaction with the top educators. And you can see this thing here. You can take the Unacademy subscription for 6 months. You will get it as a 32,245. In addition to this, by using a referral code of BV Reddy, you will get additional benefits. Additional 10% discount आपको मिलने वाला, right? And you can take the Unacademy subscription with the EMI without paying any additional charges. You can avail this Unacademy subscription, and this EMI facility, it can be approved within 2 hours, and minimal paperwork and flexible tenure. We have 6 months, 12 months, 18 months, according to your convenience. You can select your tenure. And for further details, you can make a call to this number. You will get the complete information. And the students who are willing for this Unacademy subscription, they can use a code of BV Reddy. Yes, then you can join with me, so to learn the each and every concept perfectly. Done? Hello. Let's continue our discussions. Yeah, how many problems we have finished previously? You can see 75 we have finished it, right? How many problems we have completed? The 75 we have completed, isn't it? Right. The next problem 76. Take this problem. When a current source of 1 ampere is suddenly connected across a two-terminal relaxed RC network at t equal to 0, the observed nature of voltage across the current source is given like this, then the network is. Understood the problem here, first of all? So here, first of all, the network is completely initially relaxed network. That means I don't have any initial values. The switch is connected at t is equal to 0, we can consider. Isn't it? Initially relaxed RC network. I can say here the switch. The switch is closed at t equal to 0. This 1 ampere current. Tell me now this is R and C. Now they ask him to find the voltage across the current source. Means they ask him to find this voltage. Now tell me this voltage expression they are asking. If you see carefully, can you tell me now initially at t is equal to 0 minus there is no supply. So what is a VC of 0 minus, you tell me? So VC of 0 minus which will be equal to 0. Why? Because which is initially relaxed. So I'm doing the Laplace domain we applied. So here this current which will becomes 1 by S and which is equal to 1 by CS. S domain. If I call this current is I of S. Now can you tell me now the voltage across this capacitor, you tell me here. If I consider the option A, so can you tell me now here अगर option A को consider किया तो क्या होगा, whether it is satisfied or not, whether it will be satisfied or not, you can see this thing here. Now tell me what we can say here, whether it is satisfied or not. So here this voltage which we can say this as V of S now here. Yes, exactly. We have assumed the first option we are identifying here. First of all, we are verifying the option A, whether it is a series connection or parallel connection or parallel combination. Either A, B, C, we are verifying here, isn't it? So just consider the option A we are verifying. So if you apply KVL on the loop now here, what I will get now here? V of S, which is given as 1 by S into R plus 1 by CS, 1 by CS into 1 by S. Isn't it? Tell me. This is my V of S will get now here. If you see carefully, if I find the inverse Laplace, then V of t क्या होगा? Inverse Laplace which could be given as R plus and 1 by C into t, inverse Laplace. As we know here, t power n, inverse Laplace of t power n. So which could be equal to n factorial by s power n plus 1, n factorial by s power n plus 1. So inverse 1 by s square. So this is now here t in Laplace transform which is given as 1 by s square now. So it will becomes V of t. Now if you see carefully, this is V of t is a voltage across my current source. They are asking to find the voltage across the current source. It is in the form of what we can say here. This I can say y is equal to, this is mx plus c जैसा हुआ कि नहीं, mx plus c, which is a straight line, isn't it? So this means the waveform they given us like this. So from this, can I eliminate the option A? Option A can't be. Now let's verify the whether the option B satisfy होगा कि नहीं. The parallel combination of RC network. Let us consider the parallel combinations. RC network we are considering here. And here which is equal to 1 amp, and this is R and C. Now I need this voltage, right? Now I need this voltage. Tell me now this voltage kya hoga idhar? Here also we can go for Laplace transform. Tell me. Here also we can go for Laplace transform. So if we see this thing here, this equivalent impedance of this network, what we can say now, Z is equal to, these two are parallel. So that means R into 1 by CS by R plus 1 by CS. So tell me how much the impedance, that is R by RCS. R by RCS plus 1, isn't it? So this is a impedance. From this voltage we can get now here, whatever the voltage. So that is V of S, which is given as this Laplace domain, which is equal to 1 by S now. So voltage which is equal to 1 by S into, this is R by, if I take the RC को common लिया तो, then it will become CS plus 1 by RC, right? S plus 1 by RC. So which will get it as 1 by S into S 1 by C. This is S plus 1 by RC. This is my V of S. This is my V of S, right? Now what we can do, we can find the inverse Laplace of this thing and we can do it now here. Instead of that, what I can do, just verification, so we can do it now here. If you see carefully, what is a V of 0 voltage at t is equal to 0, which is equal to 0. As t tends to infinity, that is V of infinity, which is equal to R na. V of infinity equal to R. So let's do verifications. Instead of finding the inverse Laplace of this thing here, now you tell me now this is. So here we can go for the, to find the V of infinity. What I can do here, I can use the final value theorem, limit S tends to 0, S into V of S, I can say. Final value theorem. So what I will get, you tell me, limit S tends to 0, S into V of S, that is 1 by CS, S into S plus 1 by RC. Yes, so what I will get now, S will get cancelled, S is equal to 0, which will get it as R. This is my V of infinity, which we got R. And so from this we can say this as option B. Yes, even if we have a doubt, what we can do here, you can find this initial value also, you can find out if you have a doubt. Then for that I can use the initial value theorem now. That is limit S tends to infinity. So this is S into V of S, initial value theorem. So this is V of 0, which is given as limit S tends to infinity, S into V of S, which is equal to 1 by C S into S plus 1 by RC. Now if you simplify carefully, kya hoga idhar? So 1s will get cancelled, s will get cancelled, this 1 by s. So this value to 0 aina, everybody. So that means we have the initial value which is equal to 0 and final value which is a R. So from this, can I say that option B is correct? Everybody? So from this, I can conclude the option B, isn't it? Clear, next problem. Next. In the circuit shown, the switch S is closed at t equal to 0. The switch is closed at t equal to 0 after some time, when the current in the inductor was 6 amperes. After some time, we don't know how much time. After some time, the current through the inductor was 6 amps. The rate of change of current through it was 4 amperes per second. Okay. Okay, when the current through the inductor is 6, at that time the rate of change of current is equal to this much. Then they ask him to find the value of inductor. Right? All of you understood the problem? First of all, you tell me. Right. Now, first of all, let us find the expression for this current. Now I can say IL of 0 minus, which is equal to 0. Isn't it? Next, IL of infinity is equal to 20 by 3. Isn't it? Now, tau equal to L by R. So this is L by 3. So I can write my IL of t expression, which is given as, tell me now here, which is equal to 20 by 3 minus 20 by 3 into e power minus 3 by L into t, all of you. This is the current expression. Right. Now we need the rate of change of current is given. So that means what we can say here, dIL of t by dt, which is given as, how much you tell me now here, minus 20 by 3 plus, that is 3 by L into e power minus 3 by L into t. So which is equal to, so this is 20 by L into e power minus of 3 by L into t. This is the rate of change of current through the inductor. This value they given the problem as, how much you tell me, 4. So here I need to find the value of this inductance. But the thing is, to find the value of this inductance, we don't know the value of time. This time is required now. So how we can get this time? For that, they has given some other additional information if you observe carefully. So when the current through the inductor is given as 6 amps, that means at some time the current IL of t, which is given as 6. So by equating this value to a 6, can I get the value of my time? All of you. So by equating this thing, what we'll get now here, which is equal to, this is 18 by 20, which is equal to 1 minus e power minus 3 by L into t. So this means e power minus 3 by L into t, which is equal to 1 minus 18 by 20. So that is e power minus 3 by L into t, which is equal to 2 by 20. So this value, which is equal to 2 by 20, can I substitute this value here? Then I can get the value of inductance मिलेगा हमको. Now you tell me now here, this is, which is equal to force which is equal to 20 by L into this value which is equal to 2 by 20, right? Simplify, get the value of inductance. How much you will get, you tell me? Which is equal to 1 by 2 now. The value of inductance which is equal to 0.5 H. Next problem. Now, after keeping it open for a long time, the switch S in the circuit is closed at T equal to 0. The capacitor voltage VC of 0 plus is given as the VC of 0 plus and IL of 0 plus we need to get. Okay. So that means they are asking just the initial values, right? Initial value they are asking to find. So now tell me at T is equal to 0 minus. T is equal to 0 minus, which is equal to steady state now, which is open for a long time. Now tell me what we'll get here at T is equal to 0 minus, which is the steady state. In steady state, redraw the circuit to tell me. Switch to open now. Switch is opened. Inductor is shorted. This is equal to 150 volts. And this is 300. And here this is 200. So this value VC of 0 minus. And here it is a IL of 0 minus. Tell me now here how much is IL of 0 minus? IL of 0 minus, which is equal to 150 by 500, is equal to 15. So it is, and which will get it as a 3 by 10.3. Then VC of 0 minus voltage, which is equal to 200 by 500 into 150. So how much the VC of 0 minus, you tell me, is equal to 60. Then so option A, easy problem now. Yes, as we know, IL of 0 minus IL of 0 plus both are equal. VC of 0 minus equal to VC of 0 plus, right? Negative कहाँ है आपको? Negative, so here see the direction of flow of current. Okay. Negative current, yeah, 1 second. Okay, actually in here they didn't mention the direction of current, right? So, fine. So here I'm taking the direction of current as like this. Okay, IL of 0 minus. Okay. Here they didn't given the direction of current. Might be he is asking, will treat it as magnitude of current. They have to mention the specify the direction of current. Assume that they ask him to find this current. Just assuming. Fine. So if they're given a downwards, take it as minus. Next. For the circuit shown, the order of the differential equation is relating from V naught to Vi. For the circuit shown, the order of the differential equation. What is the order of the differential equation? They are asking. So generally, the order of differential equation, which will depends upon the memory elements, the number of memory elements. And you can see now here how many memory elements are there here. You have to see how many memory elements are there. So look at now here we have a two capacitors. We have these two capacitors are parallel. I'll combine these two. I will combine these two capacitors. You tell me. I'll combine these two as a single capacitor maybe. So here whatever the values will combine will merge a single one we can merge now. Even though that is a two capacitor, it will behave like a single capacitor only. Yes or no? Whatever the values may be equal, may not be equal, I will merge it. A parallel connection now we can simply C1 plus C2 we can do it. What are the values? If I say this is C1 and this is C2, then C1 plus C2 hoga na. Now here, now should we call this as the two capacitors? Now should you call this as two capacitors or one capacitor? Hmm? That will be called as single capacitor or not? And we need to treat that as a single capacitors, isn't it? So it will combine as a single capacitors. Now here this voltage which is given as a Vi. Now tell me now how many capacitors are there here? Now tell me. C1, let us call this is my C2, this is my call as C3. How many? So can you tell me the order in this case? What could be the order? You tell me now here. So now if you see carefully, what is the voltage across this capacitor? What is the voltage across this capacitor which is always Vi? Yes or no? Always Vi. So then whether this capacitor is exist, this node voltage हमको पता ना. So here whether this capacitor will exist or not exist, कोई effect नहीं होगा, isn't it? So here even though there are these many capacitors are there, so this effect of this capacitor is nothing. Now tell me. So effectively we have how many capacitors in the network should be treated? You tell me. I need to find the relationship between the V naught and Vi. So like a transfer function we need to find. इसका C1 का effect कुछ भी नहीं होगा ना. So that is like we need to find. So here they are asking to find when you're doing the V naught by Vi, they are asking to find what could be the order. So can you tell me the order of the circuit क्या होगा? We have two memory elements are there. Can tell me now what I can say order in this case which is equal to 2. Tell me all of you. Yes. Now first, for example, let us consider I have given some circuit I have given like this. I have given some circuit I given as like this. order equal to number of capacitors. Yeah, you can do the Laplace domain. By doing the Laplace transform, it will take so much of lengthy. Simplification will take so much lengthy. See this thing here. Order equal to number of capacitors or number of memory elements, we can say. So we need to see if there is a possibility is there, you need to merge them. If the possibility is there, you have to merge it without. So here we cannot say. So let us say we have a, so these many capacitors we have, keep on we have. Can you tell me the order of this thing here? Can you tell me order here? Order of the circuit, you tell me. So here this all these things, all these capacitors, I can possible to merge as a single capacitor. Can you find the equivalent of all these capacitors? Isn't it? Isn't it? I can find the equivalent of all these capacitors. Now what I can do here? So after finding this thing here, I can simply make it as a this as a one simple network. I can keep it as like this. Now here you tell me now this is the circuit. You tell me. Can you tell me the order here? For that we need to view the order of the circuit. What is the order, you tell me? Is equal to 1. Understand, you tell me? By just seeing the capacitors we cannot say. So here if it is any possibility to merge the capacitors and combine them, get the values. So in the same problem, let us say they have given some circuit like this. Now R1, this is R2, this is R3. C1, C2, C3, and this is C4. And this voltage is V0. Now tell me the order in this case. What is the order of the circuit? You tell me here. So I will combine these as single capacitors. Yes or no? But here this voltage we don't know. Here we have resistance is there now. So we have to this capacitor also effective 1. I should treat this as a capacitor 1 and this is the second one and this is third one. Yes or no? 3 memory elements are now. So in this case order is 3. All of you? Okay. So just by seeing the number of elements, we cannot say the order. If there's any possibilities there, combine them. From that, we have to give the order. Next. In the circuit shown, the switch K is closed at t equal to 0. The switch K is closed at t is equal to 0. The circuit was initially relaxed. Which of the following sources of V of t will produce maximum current at t equal to 0 plus? Yes. Now you can try this thing here. Hmm. What's the option? Right. So here tell me, can you tell me initial value? What is the IL of 0 minus is equal to 0. IL of 0 minus is which is equal to 0. Yes, tell me now here. What about this IL of 0 plus is also 0 only now? IL of 0 plus which is equal to IL of 0 minus. Yes or no? This relation satisfy for only for the practical signals only? For practical signals. Yes or no? Practical sources or signals. Only this property can satisfy, isn't it? So that's why what happens to tell me now here, IL of 0 plus, what about the current in the network at T is equal to 0 plus, you tell me? For the practical sources which is equal to 0. If it is 0, if this current is 0, tell me the what is the voltage now, you tell me? What is the voltage? Voltage तो 0 होगा कि नहीं? Hmm. So here this which will be produce a maximum current for what values of V of t. So if the V of t is a voltage source, is unit step signal, ramp signal and step plus ramp, all these are the practical signals. Yes, unit steps case, ramp case and this thing. So all the cases, the current at t is equal to 0 plus is 0. Isn't it? But the thing is, as we know here, IL of 0 plus is not equal to IL of 0 minus. When IL of 0 plus is not equal to IL of 0 minus, for what type of source you tell me? For in case of a impulse. Yes or no? For the impulse source, this property not applicable, you tell me, isn't it? So that means what is IL of 0 plus, which is equal to, that is IL of 0 minus plus 1 by L into from where to where? 0 minus to 0 plus and V of t into dt. For all the practical signal, this value 0. But the ideal signal, so IL of 0 plus, that is impulse signal, which is equal to IL of 0 minus plus 1 by L into, that is 0 minus to 0 plus, that is del of t into dt na. So this value IL of 0 minus, which is equal to 0 initial value. So this value which is equal to 1 by L. This is only the maximum current. So here the maximum current will passes through the network in case of a provided the my V of t must be equal to what, you tell me? Provided the V of t must be equal to impulse signal. Right? So what's the option, tell me? Yes, all these signals are practical signals. The signal which can exist only at t is equal to 0, that is ideal signal. You see this thing, what is the u of t? Basically, how the u of t step signal which has been defined. You will get to know more clarity in the signals. So, what is a u of t? Basically, which is defined as 1 for what, to tell me now here? T greater than 0. T greater than 0. So how we have a signal, you tell me now here? This u of t at t is equal to 0, this value 0 only. Yes, and actually so here the signal which can be slowly will goes like this. Almost within a small time, it will reach us to like this. This is the basically u of t. And here this is signal which is equal to 0 minus and 0 plus. Like this, slowly. And what about this R of t? Tell me here, which is equal to t. So that means how we can say R of t now here at t is equal to 0. At t is equal to 0, what is the value of here which is equal to 0? T is equal to 1. So this value, yes, 1, 2, 3 we have taken. It will rise slowly, will increase now here. Right. So this signal which could be like this. This is my ramp signal. So here before that it is completely 0 and which is starting from here. So if we ask the value at 0.001, what is the value of the this R of t 0.00001? So this value which is equal to R of t value which is equal to 0.0000001. Isn't it? So that these are the practical signals. But the impulse signal, which is an ideal signal, impulse signal which can exist only at t is equal to 0 only na. But t is equal to 0 signal practically cannot be possible. Then, okay, the next problem. Right. So up to here, I think so. We have continuously we have YouTube classes only up to seventh. Up to seventh, we have continuously YouTube classes only. Right. Take the next problem. In the circuit shown C1, C2 given as a 2 farads and the C1 has a voltage of 20 volts when the SC is open. If the switch SC is closed at T equal to 0, the voltage VC2 will be, VC2 is. So initial value of the C1 given 20 and C2 is 0. They ask you to find the values. So let us see this thing what we can do here. We can go for the Laplace. Why? Because we have two capacitors and inductors are connected. This is the ideal situations, isn't it? Let us go for the Laplace now. Draw the circuit at t is equal to 0 plus. T equal to 0 plus. If we try the circuit, tell me what happens. You tell me here at t equal to 0 plus. Inductor to no. Inductor does not have anything now here. Inductor capacitor C1 only having some voltage. Initial value. This is my L and C2 value which is equal to 1 by 2. I can say 2S directly SL and this value 20 by S Laplace domain 1 by CS. The value given the value given as a 2. Right. Now, so we need to get the voltage across this. This is my V2 of S. Tell me, so can we apply the VDR here directly? So this is only single source, all are resistors. This is resistor, this also resistor, this also resistor only. Tell me what we can say here. We need the voltage across. This is 1 by 2S by, so this is 1 by 2S plus 1 by 2S plus inductance value not given. Yes, L into 20 by S. Now simplify what I will get. Simplify what I will get here. So this is 1 by 1 by 2S plus 1 by 2S. So it will be a 2 plus, okay. So this is, now this is 2 S square into L into 20 by S. Check it all of you. Now T is equal to 0 plus. This is for T greater than 0. This is T greater than 0. Yeah, correct. Now V2 of S, and which is equal to what we can say here. This is 20 by S. Now I can say 10 by S, 2 cancel. I can say 2 take common and will get cancelled. That is 10 by S by what I will get now here. This is S square L plus 1. Check it. Now this which we can modify, this L common we have taken. This is 10 by L common. Then it is S into S square plus 1 by L. Check this thing all of you. Get like this now. Now if we see carefully this expression V2 of S, you can write it as in the form partial fraction. This is A by S plus B by S square plus 1 by L. Isn't it all of you? We'll get like this. We'll get like this. If you want to simplify by taking the equating, we can get the E and D values. But lekin, so we can just verify from the option say. So if I take this thing here, this expression something. So here I can say this is V2 of S, which we may get something K, okay, something K, or let us say something A will come, A from some whatever the values will come. This is, so here we can say something A, here, K, whatever we can say, okay. From this we can say something here, yes, K1, it may plus or minus, and this is plus K2 into, I can say here, which will get it as a sign. Why? Because which is equal to this thing now here, S square plus A square form now. So which will get it as a T by square root of L. ऐसा आएगा, check it. Something. Why? Because as we know here, Laplace transform of sine AT is equal to A by S square plus A square. Some constant will come. So here ऐसा आएगा ना, it may plus or minus. So I can definitely eliminate the option A, B, C or not at all. It is not a fixed value, now tell me. It is a variable quantity. If we want complete solution, get the values of A and B constants. Then I can conclude the option D might be the correct option, which is the combination of a DC plus sinusoidal voltage. It is a sinusoidal, I can say. Yes, everybody. Is it clear? Tell me. हाँ कि नहीं यार, बोलो. Yes. Any doubt in this thing? कोई चर्चा चाहिए तो बोलो इसमें. If you want further, we can simplify. But thing is, there is no use of it. Yes, it is time consuming. That's all. Okay, next problem. The circuit shown in the figure is in steady state when the switch S is closed. The current I of t after S is opened at t equal to 0 is. So initially switch, the network is in a steady state. Fine. Now t is equal to 0 minus. At t is equal to 0 minus, the network is in steady state. Let us get the initial values now. First of all, initial values. Can you tell me the initial values क्या होगा? So this is capacitor is open, inductor is shorted. So that is IL of 0 minus, which is equal to 1 ampere. Now VC of 0 minus, which is equal to 2 volts. Check it, all of you. Directly we can write. Now for t greater than 0, let's draw the circuit now here. For t greater than 0, क्या हुआ यार? Draw the circuit. So this is now t is equal to 0 minus. Your switch is closed now. Switch is closed. Resistor, inductor is shorted, and capacitor is open. This is VC of 0 minus, and this is IL of 0 minus. क्या होगा? Tell me. So here, this is open path. There is no flow of current, right? Yes, a complete current. If I say I, this complete current will go in this path only. Will go now. So IL of 0 minus, which is equal to 2, right? 2 by 2. Right. Now let's see the t is equal to 0 plus. Now for t equal to 0 plus, no, t greater than 0 we can write. T greater than 0, let's draw the network. Tell me the draw the network for t greater than 0. Inductor. Inductor has initial current now. Capacitor has initial voltage. For this resistance, which is equal to 2. This is also 2. Switch is open completely. And here we have 1 H. And this current is 1 and capacitance is 1 by 4 farads. And this is 2 volts, isn't it? Now we can go for S domain, Laplace transform. So it will becomes what you tell me now, yes, which is equal to 1 by S hoga. This is 4 by S and this is 2 by S. Now I can apply the source transformation for inductor. We write the source transformation and we have a resistance. And so if we multiply here, so it will become say voltage source now this is a capacitor, right, and which is equal to 2 and this is 2 and this is 4 by S ohms and which is equal to S, right. SS will get cancelled now here. Right now this is 1 volt here and this is S ohms and this is 2 by S, isn't it? Now what we need to tell me now here, they are asking to find the current. So this current they are asking to find, right, means this current, right? I of t we have to find. This is my I of S. Let's find the I of S. Tell me. I of S, which is equal to, so this is 2 by S plus 1. So here this source and this sources are adding now, plus 2 plus 2 plus 4 by S plus S. Check it all of you. So then it is S plus 2 by S by what I will get now here? This is 4 plus 4 S plus S, so square by S. So then which will get S plus 2 by S square plus 4S plus 4. Check it now here. This is my I of S. So from this I of S, which is given as S plus 2 by, this is S plus 2 whole square. So the current I of S, which is equal to 1 by S plus 2. So from this I of t, which is equal to e power minus 2t, from this, which we can say this as e power minus 2t. So the option which is a decreasing exponentially now, that means which is decreasing exponentially, isn't it? Option A. Then everybody completed, all of you? You can ask. Right. And tomorrow also we have a YouTube class only. Tomorrow also we have a YouTube class, same timings, 7 p.m. Tomorrow also we have a YouTube class, same timings we have a class. Right. Fine. Okay. Yeah, that's for the today's session and we'll meet tomorrow. Okay, then see you. Bye bye.